I'm Travis Benner, and this is Next Generation Science. This video is meant to show how teachers in the field can integrate the Next Generation Science Standards into their curriculum. The activity you're now going to see correlates to the physical science standard, which is support an argument that the gravitational force exerted by Earth on objects is directed down. Now they offer a clarification statement. Down is a local description of the direction that points toward the center of the spherical Earth. And they also offer an assessment boundary. They say that at 5th grade, assessment should not include mathematical representations of gravitational force, so this is not to be focused on Newton's second law. What are you going to demonstrate for us today?
I'm going to demonstrate this piece of paper falling and see what it does.
Okay. Try that again.
See what it does? It goes back and forth.
What if you held the paper vertically or straight up and down instead of sideways like that?
It turns sideways and it keeps doing it.
Okay, so now what else were you going to do with that piece of paper?
I'm going to wad it up. The ball. I'm going to drop it. And it doesn't go back down.
Do that again.
It just falls straight down.
When introducing any new concept in science, it is good practice to have students record what they already know and to share questions that they have. This helps provide the basis for how to approach student debate and any direct instruction. Students should also record observations of demonstrations and explain what they see. This gives further evidence of what students understand and helps identify any misconceptions they hold. How does gravity act differently on different shapes?
Well, I think if bigger objects, it takes slower time because the gravity has to go all around it to push it down. And if it's smaller objects, then it has all of it's going down and it has more speed.
It's gravity pulls on it the exact same. It's just that the way that the feather's built is the air gets pushed up, so it goes up because it's so light. The air pushes it up, and in the book it just goes straight down.
The feather fell at an angle. What does that mean?
Well, I think the feather fell at an angle because I saw the white part of the feather. It had less air to go through, less space to go through than the other side because the other side had less feathers on that. So I thought, since it was going this way, the feather, I thought that it was more heavier on the white side than the other side.
So does gravity pull straight down or does gravity pull at an angle?
I think gravity pulls at an angle,
Okay.
depending on how heavy and light it is.
Okay, you think gravity pulls at an angle depending on how heavy or light it is?
Yes.
Oh, she's saying gravity still might pull at an angle? What do you think?
I disagree with that because with the feather, it kind of goes with what Jordan has to say. It's a lot lighter. It has more feather, and back here, these feathers are way lighter, and it's kind of like a dart because if you were to go and drop it, this is kind of like an arrow tip, like a broadhead, kind of. And if you were to drop it, it goes at an angle. It goes kind of like an arrow.
So it goes kind of like an arrow, but talk about gravity then. Does gravity make it go at an angle or does gravity pull on it straight?
I think gravity pulls on it straight because if you were to go to get the book that we dropped earlier, the book doesn't have any holes in the feather at all, and it doesn't have any holes in the book, and the feather does. So the air goes up through it, so it's harder for it to go through the air because it's not like a solid object. It has holes in it.
Do you have more to say about it? What do you have to say?
They pull the same, but it's hard for it to go through the air. It's harder for it to go through the air because it blocks it from coming down.
What blocks it from coming down?
The air. If it's a ball, it comes down perfect. It comes down perfectly because it can go around it. But if you have it like cupped, and it's light, it falls pretty slow. But if it's flat and heavy, it'll go down fast. It'll go down fast because it's heavier and the wind goes away from it. And it pushes the wind away, and it keeps going, and it drops faster because it keeps on pushing it away.
So gravity pulls on the feather in the book.
It pulls on it the same, but it's harder for it to go through the air.
Say about whether gravity pulls straight or at an angle.
If it pulled at an angle, that book would have been falling at an angle, but it was falling straight. So that's why I think there's more weight right here to make it fall down on that side, like drop like that.
Okay, so you think the gravity, if it pulled at an angle, the book would also travel at an angle?
Yeah.
And so why does that feather fall at an angle instead of straight if gravity pulls straight?
The weight of the one side of the object of the feather.
Okay, so gravity pulls which direction to you?
Straight.
Say about what he's claiming about the structure of that feather.
Well, yeah, it's probably the structure because, like I was saying, there's not that much weight to it on this side as there is on this side. So that's why it will glide this way. See, this side is a little bit heavier, so it's going down before the side because it's lighter. So pretty much like that book that we were doing, it was totally equal. So that's why it was going down the same and faster than this one, because maybe this one is heavier. That's why it's going down at this angle. That's what I think.
So does gravity pull on it straight or pull on it at an angle?
I think it pulls at it straight now because of the different objects can pull it different ways.
Because of why?
Because it could be this different sides can be lighter, different sides can be heavier, or they can be equal and they can go down the same level.
Okay, so and so gravity pulls which direction?
Straight.
If you want to see more videos like this one, or learn more about NextGen Science Standards, go to YouTube and search for Benner Science and like my page. Remember, it's teachers like you that make a difference. Thanks for watching.